Welcome back to the deep dive. We're here again to really crack open some complex topics and pull out the insights that matter most for you.
That's the plan.
Today, we are plunging right into the world of AI coding agents, specifically Claude Code.
Yep, a big one.
And our mission really is to figure out how you can harness all that, well, that immense power it has without feeling totally overwhelmed or losing your grip on the actual code.
It's a balancing act, for
Well,
sure. We're talking about unlocking a way to build things that's smarter, faster, but also crucially more controlled.
exactly. Controlled is key.
Right. So you shared your sources, and we've really dug in trying to distill them down into actionable strategies, things you can actually use.
Good.
We'll get into some surprising stuff about how it handles parallel tasks, some really critical tips for managing its memory.
Oh, that's important.
Yeah, it really is. We'll try to redefine what this whole vibe coding thing actually means in, a modern AI-driven world.
Yeah.
So whether you're like a seasoned pro just looking to optimize things, or maybe you're just really curious about making AI a true co-pilot.
Which many people are.
Absolutely. Then you should walk away with some pretty powerful aha moments today. That's the goal.
Fantastic. Yeah, this deep dive, it's all about giving you that edge, making AI work for you, save you time, and hopefully deepen your understanding of how this whole landscape is, well, shifting so fast.
Couldn't have said it better.
All right, let's get started then. Okay, let's unpack this first big idea. We're kicking off with something called subagents, which sounds a bit technical, but it seems fundamental to using Claude Code on bigger projects.
It is, yeah. And subagent isn't like an official term you'll find buried in the documentation.
Right.
It's more of an operational reality, how it works in practice. Basically, when we talk about subagents, we're talking about these lightweight, sort of independent instances of Claude Code, like little mini Claudes.
Okay, mini Claudes, I like that.
Yeah, and you launch them through something called the task tool. But here's the real game changer. Each one gets its own context window.
Ah, okay. Explain the context window again quickly.
Sure. Think of it as Claude's short-term memory, everything it can see and directly reason about right now.
Got it.
So having these separate context windows means these subagents can dive deep into totally different parts of a huge code base or research different things without getting confused or, blowing up the memory limit of your main chat with Claude.
That makes immediate sense for large projects. You avoid that context confusion.
Exactly. It's like having a team of highly focused specialists working for you, all at the same time.
Okay, so these subagents, these specialists, they run within tasks. Tell us more about this task tool itself. What's its main job?
So the task tool is Claude Code's built-in way to spin up these independent agents. They're designed for autonomous research and analysis.
Autonomous? Okay.
Yeah. It really shines when you need to explore a code base, but you don't know the exact file paths. Like you could ask it, find all the config files, across the whole project.
Broad search.
Exactly. Or for really research-heavy tasks where it needs to digest a ton of information.
Yeah.
Or, as we mentioned, splitting up independent subtasks to run in parallel.
Makes sense.
And, importantly, it takes the load off your main conversation. Keeps that main chat cleaner, more focused, reduces the cognitive load, basically.
Okay, that's clear. So it's for broad exploration, heavy context lifting. When should you actively avoid using the task tool? When is it the wrong choice?
Good question. You wouldn't use it if you just need to read one specific file you already know the name of.
Right.
There's a dedicated read tool for that. It's much simpler. And it's not ideal for searching for, say, specific class definitions. The glob tool is usually better for that. Think of glob as like a smart search, specifically for code structures. And you definitely wouldn't use it for just writing code directly or running simple bash commands in a really narrow scope. Again, other tools are just more efficient for those specific jobs.
Got it. So choose the right tool for the job. Now, this next part, based on the source material, is genuinely surprising. It kind of flips a common assumption about parallel processing.
Yeah, this was interesting.
Someone tried building a task queuing system, right? Expecting tasks to sort of stream out. One finishes, the next one starts.
Right, the intuitive way you'd think it would work, like a pipeline. Run 4 tasks in parallel, and as soon as one slot is free, pull the next task from the queue. That was the expectation.
But what actually happened when they specified the level of parallelism, like
Yeah.
run 4 parallel tasks?
Okay, so here's the twist. When they explicitly told it run 4 parallel tasks, Claude Code ran those 4, and then it just waited.
Waited for what?
Waited for all 4 of them to finish before it even looked at starting the next batch of 4.
Huh. So it acted like a batch processor, not a streaming one.
Exactly. Which is totally counterintuitive if you're thinking about efficiency.
That is counterintuitive. So, okay, if telling it how many to run leads to this weird batching, what happens if you just don't tell it? If you don't specify the parallelism level? This is the key insight, isn't it?
This is the absolute core aha
Yeah.
moment from the source, yes. When you don't explicitly set that parallelism number in your prompt,
Yeah.
Claude Code automatically pulls the next task from the queue the instant one finishes. It just does the streaming execution you'd expect.
Wow. So it's actually smarter, or at least more efficient, if you let it manage the parallelism itself.
Pretty much, yeah. It defaults to a much more efficient streaming model.
Okay, that's wild. So what did the testing show? Is there a limit to how many it can stream in parallel when it's managing it itself? And how big a queue can it handle?
So the observations were that Claude seems to cap out at running a maximum of 10 tasks truly in parallel, even when it's doing this smart streaming.
10 tasks.
Okay. But, and this is important, it can queue and manage a much larger number of tasks behind that. The example given was successfully handling 100 tasks. It just ran them in rolling batches of up to 10, constantly pulling the next one as soon as a slot opened up.
That's still incredibly powerful, handling 100 background tasks. Yeah.
Absolutely.
So for everyone listening, what's the really practical advice here? How do you get the most out of this for parallel tasks, saving time and, I guess, tokens too?
The advice is surprisingly simple, unless you have a very specific reason why you need to limit or throttle the execution speed. Just don't specify the parallelism level in your prompt.
Let Claude decide.
Let Claude decide. It will almost certainly use that more efficient streaming approach, pulling tasks as slots free up. And yeah, that's a huge win for big jobs, both in terms of time and token usage.
Because fewer tokens means less cost, potentially faster processing.
Exactly. Managing those tokens wisely is key.
That's a fantastic insight. Could genuinely change how people use the task tool. Okay, let's shift gears a bit. Moving from task execution to optimizing the overall workflow. There's a feature mentioned as underrated and some really crucial memory management stuff. First up, plan mode. Why is this supposedly underrated feature so valuable?
Plan mode is, yeah, I agree, genuinely underrated. Its real power is that it helps you shift error detection way early in the process.
Shift left, as they say.
Exactly. You catch architectural mistakes or, logical flaws before you've written a single line of implementation code.
How does it work?
You hit Shift plus Tab twice in the interface, and boom, you're in plan mode. Now you can just brainstorm with Claude, explore different solutions, ask for feedback on your ideas.
Ah, okay.
You can pull in context using @reference, or even connect it to VS Code using ID to select specific lines of existing code and ask questions about them while you're planning.
Oh, that's neat. So you can reference existing code directly in the planning stage.
Yeah, and you basically just iterate on that plan with Claude until you're happy with it, until it feels solid. Then and only then do you switch over to the auto-edit mode for Claude to actually implement it.
So it's more than just planning. It's like pre-debugging your whole approach.
That's a great way to put it, pre-debugging.
What kind of scope is it best for? Like small fixes, huge features?
It seems to hit a sweet spot for, let's say, smaller scopes.
Mm-hmm.
Tasks you could reasonably plan out and mostly execute within maybe 30 minutes or so.
Okay.
It really encourages that rapid cycle, plan, code, debug, commit. Iterate quickly.
And the benefit?
The big benefit is you pretty much eliminate the need for separate planning documents, Word docs or whatever, for these smaller features. You're refining the strategy right there with the AI in your development environment. And trust me, it's way easier to adjust a plan than it is to refactor code that was built on a shaky foundation.
Absolutely. Easier to change words than working code. Seems like it fits well with agile or trunk-based development too.
Perfectly. Small, iterative steps based on a solid plan.
Okay, great. Huge efficiency gain there, potentially. Now let's talk memory management. This feels critical for any AI agent, right? Getting this wrong must cause problems.
Oh, definitely. It's crucial. If Claude runs out of context or gets confused by old information, things go downhill fast.
So what's the TLDR? The quick summary of best practices for Claude Code's memory.
Okay, nutshell version. Keep your main configuration files, the clayled.md files, really minimal. Prioritize using clear to get a fresh context for new tasks. Break down really complex tasks into smaller chunks. And leverage your docs folder for storing project-specific knowledge.
All right, let's break those down. First, those clayled.md files. There's a cascaded system. What's that, and what should actually go in them?
Right. So Claude uses this cascaded system. You've got a global one in your home directory, like home.claudeclaude.md. Instructions there apply to all your projects.
Okay, global rules.
Then you can have another one right in your project's root folder, project root.clauded.md. That one's for instructions specific just to that project.
Project-specific rules override or add to the global ones.
They add to them, yeah. But the really critical point is keep both of these files lean. Minimalist.
Why minimal?
Because everything in them gets loaded into the context window every single time you interact with Claude in that project. If you stuff them full of nice-to-haves or verbose explanations, you're just eating up valuable context space that Claude needs for the actual task at hand.
So only put things in there that are absolutely essential for every session.
Exactly. Things like maybe core engineering principles your team follows, or specific folder naming conventions, or maybe things Claude should absolutely avoid doing, like don't create excessive inline comments. Truly universal stuff for that context.
Okay, be lean. But you still need to give it enough context, right? So how do you strike that balance between being specific enough to guide it, but not overwhelming it with detail in those core files?
It's about clarity over just dumping information. So instead of just writing follow solid principles, which is pretty vague for an AI, what does that really mean in practice? You might provide a very brief, human-readable summary of what each principle means to your team, or how you specifically apply it, like one sentence each.
Giving it your team's specific interpretation or flavor.
Precisely. It gives Claude concrete guidance without adding pages of textbook definitions to the context window every single time.
Makes sense. Okay, this leads nicely into clear versus compact. I know I've wondered about this. What's the real difference, and when should you actually use compact? Because it sounds useful, like compressing the history.
Yeah, it sounds useful, but the advice is pretty strong here. Clear should be your default.
Okay, why?
Use clear when you're starting a new, distinct task, or whenever you feel like the previous conversation isn't relevant anymore and you just want Claude to have a completely fresh slate. It just wipes the current conversational context clean.
Simple enough, so compact.
Compact asks Claude to try and summarize the current conversation to save space in the context window. The problem is twofold. One, it's apparently quite slow, can take a minute or more sometimes.
Oh, okay. That's not ideal.
And two, and this is more critical, that summarization process can actually reduce the fidelity of the context. The summary might miss important nuances or details from the original back and forth.
Like lossy compression for conversations.
Kind of, yeah. So the strong recommendation is only use compact as a last resort. Like if your context window is almost completely full, but the history of your current session is absolutely vital to continue the task right now.
And if that's not the case?
If that's not the case, using clear and maybe briefly reminding Claude of the key points, or just starting a completely new session is usually much faster and more reliable.
That's a really practical tip. Avoid compact unless you're really stuck. Okay, so if the Claude.md files need to be lean and compact is risky, where do you put all that detailed project-specific knowledge? Architecture diagrams, design definitions, specific APIs to use.
That is exactly where your project's docs folder comes in. This is the recommended place.
Just standard markdown files.
Yep. Create markdown files inside a docs directory in your project. Put your architecture notes, your specific guidelines, API documentation links, whatever detailed context Claude might need for this specific project.
And how does Claude access it?
Then, when you're talking to Claude and you needed to know about that stuff, you just reference the file using the @ symbol, like at docsmyarchitecturenotes.md.
So it pulls it into the context only when explicitly needed.
Exactly. It keeps your main context clean and focused most of the time, but lets you pull in rich, specific information on demand, saves tokens, keeps things relevant.
This is all about working with the AI's strengths and limitations, isn't it? Not fighting them.
Precisely.
And speaking of leveraging its intelligence, the source material had this really interesting UltraThink prompt example. It was designed to get Claude to create super detailed implementation plans. Can you describe that prompt and what it tells us about guiding Claude's, well, deeper thinking?
Yeah, the UltraThink prompt is quite something. It's a great example of highly structured prompting. It went something like, UltraThink, please create a detailed implementation plan based on at docsarchitecture.md. So first, it's referencing that external doc.
Right.
Then it gets specific. The plan should have an MVP section and a future enhancement section. Under each section, create milestones. Under each milestone, create action items.
Wow. Very prescriptive.
Very. It even specifies formatting. Prepend to each action item so they can be checked off,
Cool.
and adds requirements. For each milestone, add an action item for writing unit tests.
And the UltraThink keyword itself.
That seems to be a kind of magic word to signal to Claude, okay, engage your deepest, most analytical processing for this. The key takeaway is how much structure you can provide in the prompt to guide Claude towards producing a highly organized, granular, and actionable output.
What strikes me here is that it's not just asking what to do, it's telling Claude how the output should be structured. The format itself is part of the instruction. So this really raises a bigger question, doesn't it? How do we as developers need to adapt how we write prompts to really unlock these deeper capabilities, to get these structured, genuinely useful outputs beyond just simple code snippets?
I think it signals a shift. We need to start thinking of prompts less like casual requests and more like structure specifications. We're defining the output format, the sections, the level of detail we expect.
So prompt engineering becomes more like defining an output schema, almost.
That's a good analogy, yeah. That level of precision allows Claude to go beyond just task execution and actually help with higher-level planning and architectural thinking.
Excellent point. Okay, so mastering planning and context management really elevates Claude as a partner.
Yeah.
Now, let's pivot to a concept that's stirred up quite a bit of discussion, maybe even controversy. Vibe coding.
Ah, yes, vibe coding.
Where did this term even come from, and what was the original, maybe slightly provocative idea behind it?
It was coined by Andrzej Karpathy, and the original idea was pretty wild. It was about fully giving into the vibes, embracing exponential complexity, and essentially forgetting that the code even exists.
Forgetting the code exists. Wow.
Yeah, it painted this picture of just constantly hitting accept all on AI suggestions, never reading the diffs, just copy-pasting error messages back into the prompt until things kind of worked.
That sounds chaotic.
It does. He framed it mostly as something potentially okay for like throwaway weekend projects where you just want maximum speed and don't care about the mess.
Okay, exhilarating speed, terrifying technical debt potential.
Yeah.
The author of our source material, though, offers a much more, shall we say, grounded take on vibe coding. What's their perspective?
Yeah, they propose a much more nuanced, balanced approach, a personal take, they call it. The first big principle is don't forget the code. Simple, but crucial. Meaning, however tempting it is to just let the AI run wild, for any project that actually matters, anything you need to maintain or rely on, you must review the generated code. Check it for security flaws, for maintainability, for basic quality. AI isn't perfect, and ultimately, you're still responsible.
Okay, maintain human oversight. What's the second principle?
Grant autonomy with caution. This tackles the accept-all idea. The suggestion is, look, maybe use auto-approve sometimes to reduce fatigue during a long coding session, get into a flow state.
Okay.
Well, but make sure you review the accumulated diffs regularly, maybe at the end of the session or before committing. And crucially, always manually approve any operation that feels inherently risky. Things like arnomofef or curl commands pulling scripts from the internet.
Right. Common sense checks for dangerous operations. It's about smart delegation, not blind faith.
Exactly. It also encourages smaller, more manageable iterations if you know you'll be reviewing.
Makes sense. And what about that dream of just using natural language, telling the AI, make the sidebar padding smaller?
That's definitely part of the appeal, and it ties into the third principle. Utilize vibe coding as much as possible. Embrace the idea of operating at a higher level, delegating the dumb things, the repetitive boilerplate or simple tweaks using natural language, like your padding example.
But there's a catch again, I assume.
The crucial addition is that you still need to provide enough detail and context for the agent to actually do the job properly. It's not magic. You have to give it enough information to succeed. Think of it as a partnership. You provide the direction and context, it provides the rapid execution. It's a win-win, but requires input from you.
Okay, so delegate, but delegate effectively. What else?
Well, they also stress apply best practices, especially for production code. All those foundational engineering principles, DRI, KISS, SOLID, the 12-vector app stuff, maybe TDD, they don't just vanish because an AI wrote some of the code.
Still important.
Absolutely. The recommendation is to keep applying them, maybe even bake them into your editor's custom instructions so Claude is constantly reminded of your quality standards.
That's clever. And the last point.
Improvise and adapt. Vibe coding isn't some rigid dogma you have to follow precisely. It's a set of ideas, a flexible approach. Take what works for you. Adapt it to your specific project, your team's workflow. Make it your own.
This balanced perspective feels much more practical for real-world development. So can we summarize this into like a mini vibe coding manifesto? What are the core tenets?
Yeah, it boils down to maybe 4 key things. 1, don't forget the code, always review. 2, grant autonomy with caution, auto-approve strategically, but manually vet anything risky. 3, flexible adoption, use vibe coding strengths for speed, but adapt it, provide context. And 4, ignore external pressure. Figure out what workflow truly works best for you and your project. Don't just chase the hype.
That's a really helpful summary. And this whole nuanced take, it really highlights a bigger shift happening, doesn't it? It forces us to ask, how do we cultivate the right mindset as developers? How do we embrace AI's power without sacrificing critical thinking, quality control, and, well, responsibility?
It's a fundamental question. This approach suggests vibe coding isn't an excuse for sloppy work, but maybe an evolution towards a more intelligent, augmented way of developing software.
Okay, augmented development. I like that. But even with careful planning and review, things can still go sideways, especially when you're moving fast with AI. So let's talk safety nets. Let's talk Git.
Git, the developer's best friend.
How does version control fundamentally change the game when you're deep in AI-assisted coding?
Git completely changes the risk-reward calculation. It's not just, a save button. It's your time machine, your undo button, your collaboration backbone.
Right.
And in the context of AI coding,
Yeah.
it basically transforms what might seem like reckless speed into safe, rapid experimentation. When Claude Code inevitably does something weird or wrong, and the source notes this happens more often than you think,
I bet.
Git means you can just discard those unwanted changes instantly, without any panic. It gives you the confidence to push the boundaries with the AI, knowing you can always roll back easily.
Freedom through safety nets. Okay, so what's the recommended Git workflow to use alongside this kind of AI-driven, potentially vibey development? Something simple and robust.
The source strongly recommends the trunk-based workflow
Why trunk-based?
because it emphasizes small, frequent, incremental changes merged directly into the main branch, or trunk. This aligns perfectly with the rapid, iterative nature of working with an AI like Claude. Keep changes small and focused.
So the basic steps.
Pretty simple. Create a new feature branch off your main branch, main or master. Do your work there, let Claude Code, maybe vibe a bit, you review. Then you add the changes and git commit.
But there was a critical warning there, right?
Yes, a very critical reminder. Before you type git commit, always double-check the changes, git diff staged, to make sure you haven't accidentally included any sensitive information, ABI keys, passwords, secrets that the AI might have hallucinated or pulled from somewhere unexpected.
Crucial security check. Okay, then what?
Once you've checked and committed, switch back to your main branch, maybe pull the latest changes, and then merge your feature branch in. Keep those branches short-lived.
Okay, trunk-based, small branches, check before commit. Got it. Now, what if, despite your best efforts, an AI change does go wrong on your feature branch? What are the practical ways to undo things?
You've got your standard Git recovery toolkit. If it's just one file that got messed up, Git restore path to file, or the older Git checkout path to file brings it back from the last commit.
Okay, file level revert.
If Claude just made one bad change inside a file, often your IDE's graphical interface is easiest. Like in VS Code, you can usually just click next to the change lines and hit revert change. Super handy.
Right, the gutter indicators.
If the whole feature branch just went completely off the rails, just switch back to main and delete the bad branch, get branch D feature name, no harm done to main.
Clean slate.
And then there's the break blast in case of emergency option for a feature branch. Get reset hard commit hash. This blasts your branch back to a specific previous commit. But huge warning sign here.
Destructive.
Highly destructive. It throws away all subsequent commits permanently. Use it with extreme caution, and never ever run it on your main branch unless you really know what you're doing and why.
Okay, reset hard is the danger zone. Use with care. Good to know the options, though. Those safety nets really do make experimenting feel less risky. Now, shifting slightly within Git commit messages, can Claude actually help write good ones?
Yes, it can. You can actually prompt Claude Code to generate structured commit messages that follow standard conventions, which is great for consistency.
How does that work?
The source gives a nice example. You set up a prompt that asks for a message in the conventional format. Type .space short summary title, followed by maybe some concise bullet points explaining the changes.
And you define the allowed types.
Right. The prompt would specify the allowed types, like feat for feature, fix for bug fix, chore, docs, refactor, test, style, perf, all the usual suspects.
How do you trigger this in Claude?
You'd save that detailed prompt as a command file. maybe in .claude commands, naming it something like gen-commit-msg.md. Then, after you've staged your changes with git add, you just type user.gen-commit-msg in the Claude Code chat.
And it drafts the message based on the staged changes.
Exactly. It looks at the diff and generates a message following your specified format and types.
That's pretty slick. But what I found really interesting was that even with this cool automation, the author explicitly advises against making it a single command that generates and automatically commits the message. Why keep that manual review step?
It comes right back to that core principle. Grant autonomy with caution.
Ah, consistency.
Yeah. Even for something seemingly straightforward like a commit message, the recommendation is clear. Let the AI draft it, but you should review it before committing.
Why? What could go wrong?
Well, the AI might misinterpret the changes, pick the wrong type, write a confusing summary, or maybe even include something sensitive you missed in your earlier check. That final human review ensures accuracy, clarity, and keeps you firmly in the driver's seat.
It's another perfect example of using AI as an assistant, a powerful one, but not abdicating your own judgment and responsibility.
Precisely. The developer remains the ultimate decision maker.
This has been incredibly insightful. We've covered a ton of ground today. We dug into the sort of hidden power of Claude Code subagents and how to manage tasks intelligently in parallel.
Yeah, the streaming versus batching thing was a key takeaway.
Definitely. Then we looked at the importance of smart memory management, keeping those claude.md files lean, using clear, leveraging the docs folder.
And avoiding compact most of the time.
Right. And we explored plan mode for shifting error checking left. And finally, we landed on this really nuanced, responsible take on vibe coding.
Balancing that speed and delegation with essential quality checks and human oversight. And using Git as your safety net throughout.
Exactly. So by understanding and, more importantly, applying these techniques we've discussed.
You're not just gaining efficiency points, you're actually getting deeper control, a better mastery over your whole development process.
Yeah, it feels like transforming the AI from maybe a slightly unpredictable black box into a genuine, transparent, powerful partner in coding.
Well said. It's about developing smarter, faster, yes, but also with more confidence and control.
So as we wrap up, here's a final thought to leave you with. As these AI coding agents like Claude Code just keep getting better and better, that line between being a developer and being more of an AI agent manager or prompter, it seems to be blurring, doesn't it?
It really does. The skill set is evolving.
So the question for you to ponder is, what new skills, beyond just writing lines of code, will become the most critical for developers who really want to master this rapidly changing landscape? And maybe more personally, how will you start preparing for that future today?